How to select correct spacer. To calculate the gradient of the sound power, a difference approximation has to be used, which only works reasonably well in a certain frequency range. In order to conduct accurate measurements, correct spacers must be used for corresponding frequency ranges. Let's take a look at what happens at high frequencies using this image, which shows such a situation. The exact value of the derivative of the sound pressure is represented by a solid line, and the dotted line represents the approximation. The wavelength of the sound wave is only about 2 times the spacer length, so the difference between the exact and approximate value is significant. The rule of thumb is that for an accuracy of 1 decibel, the wavelength of the measured sound must be at least 6 times the spacer difference. At low frequencies, a different situation arises. When the sound wave is very stretched out, the difference in sound pressure between the microphones is low. In other words, the phase difference of the signals from microphones A and B becomes small and is comparable to the inherent phase mismatch of the system, which is always present in the microphone and in the analog components. To maintain the desired accuracy, the phase difference between the microphones must always be sufficiently larger than the inherent phase mismatch of the measurement system. One way to increase it is to put the microphones further apart using a longer spacer. This will enable an accurate measurement to lower frequencies, but will at the same time decrease the upper frequency boundary for reasons explained at the previous slide. The length of the spacer therefore influences the lower and upper limit of usable frequency range. With a single spacer, an octave and a half can be covered. So to sum up, the upper limit is determined by the finite difference approximation error. The lower limit is determined by the inherent phase mismatch of the measurement system, particularly due to microphones. By combining spacers of different lengths, a frequency range from 20 Hz to 10 kHz can be covered. The image on screen shows the usable frequency range for various standard spacers. When the spacer length is inserted in sound intensity setup in Dewesoft, a recommended frequency range is displayed.